Hi everyone, welcome back. We're going to continue with our notes of quiz 7 talking about systems, but we're going to do things algebraically now. Let me fix the focus. Alright, on the left-hand column, you'll see systems with linear and linear, and that are linear systems by name, which we've done in the past, and then we're going to see how that same style will look in a nonlinear system. All right, we're going to start with some Algebra 1. If we said solve by substitution y equals 2x minus 1 and 3x minus y equals negative 1, I notice that there's already a y equals by itself, so I'm going to take this and substitute it into the other equation where y is with parentheses. So if I do that, we end up with 2x minus 1 equals negative 1. And we're going to distribute our negative to get 3x minus 2x plus 1 equals negative 1. And I can combine like terms to get x plus 1 equals, and subtract 1, negative 2. If I subtract, right? Yes. This became plus. If I subtracted, we end up with negative 2. And that's it. We have x equals negative 2. I did too many steps as one. So we have x equals negative 2. Now I can take this answer and plug it into either one of these. And I'm just going to plug it into the first one. So you have y equals 2 parentheses. We now know x is negative 2. That gives us negative 4 minus 1 and an answer of negative 5. So y equals negative 5 and x equals negative 2. Your answer is always a coordinate point. It's where they intersected on the graph. And in our case, it's negative 2 and negative 5. That's the linear systems. If we approach it the same way, but for a nonlinear systems, we're going to see what happens. If I have something already y equals, I can take that and substitute it to the other equation, where I get 2x minus parentheses, the 2x squared minus 1 that we're substituting equals 1. Just like over here, we're going to distribute the negative to get negative 2x squared plus 1 equals negative 1. And let's see what we can do. I'm going to move the 1 over. So I'm going to add 1 on both sides. Is that a possibility? Plus 1. Let's see. We have negative 2x squared plus 2x. And yep, I'm going to move this guy over to get plus 2 equals 0. And if I factor out a negative 2, we can get x squared minus x minus 1 equals 0. Feel like I made a mistake somewhere. Let's see. 2x minus 2x squared minus 1 becomes negative 2x squared plus 1. Oh, I copied it wrong. Duh. There should be a plus 1 plus 1. So if I subtract 1, these go away. This is why we check our work. So we are up until this point. That's my bad for copying things wrong. If I can factor out a negative 2x, we're left with x minus 1. We factored out the GCF. They both have a negative 2, and they both have at least an x. Now that I have this, I can take each part and set it equal to 0. And solve separately. So if I divide by negative 2, we get x equals 0 and x equals positive 1. Now I got to figure out what y values go with each of those x values. So if I take the x equals 0, it doesn't matter which one I plug it in. I'm just going to plug it into the first one. We're going to do 2 times 0 squared minus 1. And I get y equals negative 1 with this 0 value. So far my answer consists of 0, negative 1. And I'm going to do the same thing with my other answer, my x equals 1. I'm going to plug it in. 2 times 1 squared minus 1. And that becomes 2 minus 1, which is just 1. So our last answer is 1, 1. Just like on the other page, we know if we have a parabola and a line, they can intersect in 2 places, and in this case they did, and those are our 2 intersections, our 2 solutions. let's keep going, and we're going to try everything by substitution. Or elimination, sorry. To do elimination, we have to align everything first. Okay. So what I'm going to do is I'm going to subtract my 1/2 x on both sides and move my -1 over, which means on the top we're going to have -1/2 x plus the y that's already there, and then I move the 1 over, so it becomes -1. I'm not going to change anything to the bottom. We're going to have 5x minus y equals 1. Now with elimination, the goal is when we add these two, either the x's or the y's cancel out. It doesn't matter. I can notice plus y and minus y is already going to cancel out, which means I don't have to change anything. I can just go ahead and add everything going down, because those go away. And if I do -1/2 plus 5 over 1, and I get a common denominator, that becomes 10 over 2. And we get 9x over 2 equals -1 plus 1 is 0. Anything times 0 is 0, which means our first x value, our only x value, is 0. And to get the y value, I can plug it into either one of these, and it doesn't matter. I'm just going to do the second one. I can do 5 times 0 minus y equals 1. Negative y equals 1, so y, positive y, should equal -1. And that means our answer is going to be 0, -1. Right. That was for linear. Now we're going to apply the same thing to a nonlinear system. I need to align everything again. So we are going to, let's see, move the 2x squared over. That moved over. I'm going to move the x over, keep the y, and I'm going to move the +1 over to the other side. I'm going to keep the bottom the same, but I'm aligning everything, which means my x has to go with the x. Since I don't have an x squared here, I'm just going to put 0x squared, because that's the same thing as nothing. And I notice again, my y's are already set up to cancel out. And we can just go ahead to add everything going down. Oops, that's weird. Things are happening that I don't know what. There we go. Sorry about that. Again, we're going to add going down. We get -2x squared. -1x plus 5x will give us a +4x. That gives us 0. And if I add -1 and 0, it's -1 and 1, sorry, is 0. I notice that -2 goes into both, and they both at least have an x. So again, we're factoring out the GCF. And if I divide everything by -2x, we're left with x minus 2 equals 0. Now we can take each part and set it equal to 0 and solve separately. So we get x equals 0, and x can also equal 2. And for each of these, they're going to have a separate y value. And I'm going to have to figure out what that y value is individually. If I take 0, I can plug it into whatever I want. I'm going to plug it into the second one. I'm going to do 5 times 0 minus y equals 1. And we get y equals -1. Now I'm going to do the same thing. I'm going to take 2 and plug it into this one. I'm going to have 5 times 2 minus y equals 1. That's 10 minus y equals 1. I can subtract 10 on both sides. And we get -9. So positive y equals +9. And that means our answer, we're going to have 2, is going to be 0, -1, because those went together, and 2 goes with the 9. Okay, got one more problem to do with you all, and then the video shall end, sadly. Here it says solve by any method, and I notice y is already solved for something. Now, I'm going to use substitution. You could use any of the other two methods that are available, but this is the one I'm going with. So I'm going to plug it in. I have 2x plus 3 times substituting in the other equation with -5. So I took this and I plugged it in to that y with parentheses. I can go ahead and distribute now to get 2x minus 2x plus 18 equals -5. Those cancel out and we end up with 18 equals -5, which is not possible. And that leads us to say no solution for this problem. Okay. If I try and do the same thing here, I notice they both equal y. So if they both equal y, then these should be equal to each other. And that's exactly what I'm going to do. I'm going to set these equations equal to each other because they both equal y. And I know this squared is the same thing as x minus 1 and x minus 1. And we can FOIL this out. And in the end, we should get -2x plus 1 equals 4. I'm going to distribute my -2 to get plus 4x minus 2. I still have the plus 1 out here, and that equals 4. I have like terms, so I get -2x squared plus 4x minus 1 equals 4. And if I subtract 4, we get -2x squared plus 4x minus 5 equals 0. Now I'm going to save you the trouble. If I try to factor it, it's not possible, which means we're going to have to try and either do the quadratic formula, or I'm going to see if it's even possible, I'm going to try and do the discriminant. If I take the discriminant, it's going to tell me how many x-intercepts we should have. So if I do that, my b squared minus 4ac gives us 16 minus, this becomes 10 and 4 is 40, but that gives me a -24. That means there are no real solutions, it's all imaginary. So we're going to say no solution for this as well. All right. Hopefully you'll be able to fill in some key important notes for yourself that you notice and you don't want to forget. I hope this helped clear things up for you. Good luck studying.